Thank you for attending this conference or symposium, and particularly my session, which you'll all find riveting, and I at least hope so. Today we're going to be discussing the astronomical heritage paradox. What is that in preservation? How does preservation butt heads with technological advancement? What are some of the big questions that come out of science? Are there correlations between history and progress? Aha! Alas, we have a great case study here today. We'll be talking about the Sacramento Peak Observatory, which is in Sunspot in Alamogordo County, New Mexico. I had to show my glasses. As I was introduced, my name is Jessica Wobig, and I've been working with Jacobs since 2018. When I joined Jacobs, I became part of a team who's working to support the National Science Foundation on some potential divestments of their historical observatory portfolio. One of those observatories was the lovely Sacramento Peak Observatory, which is known by locals as Sunspot. Seated at 9,200 feet above the Tularosa Basin, overlooking the White Sands National Park, historically the White Sands Proving Grounds, and Holloman Air Force Base, Sunspot was selected not just because of its picturesque location, but because of the applied potential to understand the skies. But what does that mean, you ask? For a preservationist, I came to the project, not an astronomical expert, not a physicist, not an engineer, and definitely not an architect. But I was asked to identify the significance of this place, explore its history, create that narrative, and work with experts who have that knowledge. But to get that, you're working with scientists who don't want to explain the theory. You're working with federal agencies who, in good spirit, are working under the National Historic Preservation Act, all trying to meet the future goals of the agency. So I'm tasked with understanding, how do we come to understand this place? How do we build that? And at the same time, if 4 of the 5 telescopes, which there's 5 telescopes at Sunspot, are already offline, how are we going to preserve this place? Does being offline change the significance or integrity of these resources? So that's what I'm asking you all to work with me today as we move through this understanding and how we're managing the legacy of the space race versus the future missions of science. Because ultimately, where's the relationship between history and science? What can we learn, and what do scientists do as they move through their understanding? So that's our goals. Using the National Historic Preservation Act as preservationists, agency representatives, photographers, politically appointed persons, we all have different roles in this, but using the National Historic Preservation Act as that fundamental guiding of our federal preservation program. Oftentimes, Section 106, which is that federal process that asks for historic properties to be considered, not saved, not protected, but considered with minimal effect, is diminished in the preservation sphere as a whole. Consultants are often presented in the light of doing project by project, and the overall spirit and intention of the National Historic Preservation Act is missed in conversation. In using Sunspot as our case study, we can start to see how the Section 106 process really can help federal agencies build their preservation program to align with their mission. Because it lays out the identification process, which they're mandated to do, create an inventory of the historic properties. It develops a standard for documentation, and it asks, how can you preserve this? If not, what can you do to minimize and document that change? But the underlying theme and thesis that I hope we all get very excited about, and as we saw yesterday in some of the presentations, the understanding of butting up against technological innovation and progress often is where we sit as preservationists. But I'm arguing that as preservationists, particularly in the sciences, if we're working with astronomers, this astronomical heritage is important to not only furthering the understanding of that discipline and field, but helping us discuss our cultural history as a whole. So that leads us to our preservation response. The National Science Foundation, Directorate of Mathematical and Physical Sciences, Division of Astronomical Sciences, or AST, identified the need to divest several facilities, including Sunspot. This came after the decadal survey, which is a peer-reviewed process to determine the future of sciences and funding, and several portfolio reviews. So it's not when we get to Section 106, a lot of activities have happened before we start considering what's next. These potential changes triggered a federal undertaking, and NSF, who's responsible for the preservation of historic properties, moved forward with the Section 106 process. But also federal agencies are required under Section 110K, well, that's another thing, Section 110, to keep their list of historic properties. So it aligns and it meets two things. So oftentimes Section 106 is just done on its own, but it is always part of that federal program. And it's not just separate from these agencies, but it's part of that larger dialogue. Because Sacramento Peak Observatory, or Sunspot, was first occupied in 1947, and a series of significant events happened, it indeed was a historic property and required consideration. Fortunately, all parties involved, which you can see the lovely list here, all agreed this is clearly a significant place. No question was ever brought about, but it was deciding, how do we build that? And most importantly, how do we identify the things within it that we can preserve to tell the story in the future? NSF worked with the U.S. Forest Service, who manages the land where Sunspot is located. Sunspot's located in the Lincoln National Forest, which is 1 million acres of forested land. Not only did the forest help create a buffer for the environmental conditions, reducing the dust in the atmosphere, making it this beautiful place to see, but it also aided to the rural nature to help with distractions and create this scientific community, which Sunspot was not just an observatory, but it was a community. In addition to the 5 telescopes, there were several stages of residential development, including the Koch relocatables, which I'll discuss a little bit later. Because it was an adverse effect, because we didn't know what could happen should this property be divested from federal ownership, the Advisory Council on Historic Preservation was brought into consultation, as well as the New Mexico State Historic Office. In addition to that, New Mexico State University, who currently at that time was running the Apache Point Observatory, which is diagonal to Sunspot, became a consulting party. The National Solar Observatory, who had previously occupied the site, was engaged as well, and individual parties joined on. So that leads us to the nits and bits and technical details. So after looking at the 135.18 acre site, and working with our experts, including the U.S. Forest Service, who has an archaeologist on staff who dedicated 5 years of their personal interest in collecting research for Sunspot, was willing to work with me, the lone consultant, to start building that story. Retired Air Force individuals also helped participate in developing the story, as well as astronomers at Sunspot and who had historically worked there and are now around the world. So it was a whole bunch of us working together as this team to move the story forward, which I hope you see is that underlying pulse of this is really all of us coming together. It ultimately was determined eligible as a district for its design landscape, so it has this site, the Sunspot Highway, which was constructed 1963, is included. So you have this oval-shaped district with this extending highway. It's parsed out by use because it was designed by Willard Kruger in the 1950 site plan. Kruger was a New Mexican architect who also designed the state capitol building. Kruger was known for his design landscapes and utilized the fractured limestone, which is a natural element of the site, to start laying out some retaining walls and curvilinear paths, and he split it out in use. So that is how we moved forward as we start looking at this site. We have our scientific area, the telescope loop, where all of the telescopes rest upon the escarpment. We have our administration area, where we have our labs. We have our machine areas where they're building the instrumentation and are caring for the property. We have our residential areas built in three large stages. One part is the Willard Kruger site plan, which is close-knit and is kind of still keeps that central loop. And this is when we're transitioning from our temporary housing, which was Quonset huts, into some of our brick structures, brick and concrete structures. By the 1960s, Carl Koch, who's known as the grandfather of prefab, brought 21 of his tech-built relocatables to the site. He sited them on existing landscape without changing the grading and worked with that to, in contrast to what was popular at the time, which is clearing, grading, and ignoring the site's specifications. Koch, on the other hand, moved all of his relocatables in a way that worked with the site. So he continued that story that Kruger started in the 1950s. You'll see that 3 of the telescopes in progress. At the top, we have the grain bin dome, which is indeed exactly what you imagine, and it sounds like a Sears catalog grain bin. It was first brought to the site in 1949 to be used as a telescope enclosure for their 4.5-inch chronoscope, which at that point had an 8-foot spar that it rested upon. They didn't complete the upgrade or modifications to the grain bin until 1950. So it had about a year of just kind of sitting there being imaginary before it was put into use. But by 1953, the Evans Solar Facility, which is also known as the Big Dome, and our central image there, was under construction and utilized. The Big Dome rotates around I think it's like a 16, or it's like 3 times the scale of the original chronograph that was on site. That was used to track solar cycles. So they're looking at trying to see when the maximum and minimum of solar activity is. To do what, you ask? Make sure that we can ascend to the heavens. So that's where oftentimes astronomy is divested from the space science sphere. But if you do not understand where and when solar activity will happen, you cannot safely launch. Interestingly, in May 23rd, 1963, or something like that, there was a solar interruption where we as Americans thought the Soviets were coming to take us down with nuclear warheads. We're at the precipice of nuclear war. Fortunately, we had some observers sitting at Sunspot monitoring the skies who realized it wasn't a nuclear warhead or the Soviets coming to get us, but just normal solar activity. That blew my mind. So as we can see, the period of significance here is broad. It starts when that first site occupation occurred in 1947, and it ends in 2015, which is when the National Solar Observatory moved back to Boulder. And ultimately, the community was shuttered. There's 77 contributing resources and 6 non-contributing. It was hard to pull out the non-contributing resources, but by focusing on use of the property, we're able to make the argument. So for example, an ISO building that was installed in the late 1990s no longer had the telescope inside. It no longer functioned or could show that, so it's a non-contributing resource. But we have it parsed out by the research, the design landscape, and a residential campus. With that, you get a 3-minute tour.
Two hours northeast of Las Cruces by way of Cloudcroft and onto US 82 East and Forest Road 63, you will reach the National Solar Observatory, also referred to as Sunspot. Perched high in the Sacramento Mountains, the magnificent skies of this region provide excellent transparency for observation of the sun. I was able to take a tour with astronomer Han to get a better sense of the work they are doing here.
So this is the grain bin dome. It houses the first telescope that was put on the site here to test its properties as a potential solar observing site. So this site originally started at the end of the 40s as an Air Force observatory The Air Force is interested in what we call space weather, the effect of disturbances that come from the sun that affect the Earth environment. The reason this site was chosen as a potential site for solar observing was twofold. A, this is high in the mountains and we have clear skies and not many clouds. And B, this site really overlooks white sands. And back then, in the end of the 40s, they just started launching some of the rockets that they had captured at the end of World War II from the Germans. And so this site was chosen because of its vantage point over white sands. And back then they needed a quick solution for housing for a telescope, so they ordered the grain bin, literally from the Sears catalog, and put it here, put a slit in the top and the sides so that they can point the telescope at the sky. And that was a good solution for it back then.
The humble beginnings.
So
let's keep on going to see how it evolved.
I'll show you the rest, yes. So this is the Evans facility. An instrument like this mimics the action of what happens during a solar eclipse, when the moon moves exactly in front of the sun and blocks the very bright disk and allows you to see the corona, the very faint corona.
And looking at this one compared to the big one, it's like worlds apart.
It's a very different instrument. Yes.
Towering above the other facilities on this mountaintop is the largest and certainly the most visually impressive of their instruments, the Richard B. Dunn Telescope.
Wow. This thing is huge.
Yes. This is 300 tons of telescope that you're looking at, and this is not all of the telescope. The telescope goes down into the ground twice as far as what you see up here.
This is 1/3 of it.
Yes. Up on the top of the telescope, you have two mirrors that track the sun during the day, that point the light through the telescope down to the bottom of the telescope, and that forms an image at about this height of the observing table. And then we have optics that distribute the light through the different instruments that are here on the table. Measure the magnetic field and measure temperatures, velocities on the sun.
That's crazy. Talk about operating heavy machinery.
This is
mega machine.
The very special thing of this telescope, that this whole inner part of the telescope actually floats. We have about 8 tons of mercury in a basin at the top, and the whole inner part of the telescope floats in that and can therefore rotate very smoothly.
The observatory is open from dawn till dusk. Though open year-round, be prepared to face winter driving conditions on curving mountain roads if you go November through April. With more limited hours, call ahead. This site is on Forest Service land and there are no gas stations nearby. Fuel up in Alamogordo or Cloudcroft before heading up.
So you heard that right. There's something like 8 tons of mercury holding up the Dunn Solar Telescope, which stands, a third of it's under the ground, about 200 feet, and about 130 feet underneath the ground, and the rest stands above, and it's 200 and some feet. It's a vacuum solar telescope which was completed in 1969. By the time it was completed, it was multiple times more expensive. Because of that fractured limestone that it rests upon, the excavation was next to impossible, and it added to that cost. So by the time it actually was turned online, Dunn was already on to thinking about how can he design space-based observation. So the irony for me as a historian is, as the instrumentation comes online, the scientist is already moving on to that next idea. So how do we as preservationists start working through the process? For those of you who may be unfamiliar with Section 106 or are new to it, it's indeed a 4-step process of initiation, identification, assessment, and resolution. Because of the unknown qualities of this undertaking, a programmatic agreement was signed in 2018, and my task was helping implement that. That led to the development of a draft National Register nomination form, and this was built on by a preservation principles plan, which includes a cyclical maintenance and mothballing provisions and a workflow of sorts. It also broke out our 77 contributing resources into 7 categories to help the operator start thinking about the property they're managing. So we included the easy things, the site, so the layout, the roads, the science-focused resources, the residential resources, the setting, and so on and so forth. But by breaking out into those categories, you're able to more easily aid the operator in thinking about the National Park Service preservation bulletins they can use, or some of the other tools like the U.S. Forest Service mothballing guide. All of that was boiled into this so that the operator has that clear history, that clear understanding of these significant features, and then the tools to implement and preserve them. In March of 2020, the week before everything shut down, we hosted a day training at Sunspot for the operator. NSF was in attendance, as well as NSO and the U.S. Forest Service. We spent the whole day talking about not only the history of the site, which, you know, when you can impress an astronomer with your knowledge of it, that was very pat on the back. But to see the inspiration that we can use astronomical heritage as not only a tool or technique to further the knowledge of science, but as a way to get us excited about our history and culture. So some of the successes to me was building on those relationships, helping, for example, the grumpy archaeologist give me 5 years of research to work from. Trust building is a huge part of the process. So regardless of where you are within it, knowing that when you're representing this, that everyone has passions, feelings, and beliefs, and by identifying those and helping them tease out those significant points, we can really apply it to something fantastic. I was very pleased that after working through everything, we were able to create that deep knowledge and help further the Sunspot Solar Consortium, who is led by New Mexico State University, who's continuing to operate the DUN, which remains the only telescope in operation today. Further their visitor center and different programming that they continue to do on site. But most importantly to me, as someone who's obsessed with Cold War and space race and cultural tensions between the US and our former Soviet relations, now Russia, it was thinking about what I do as a preservationist a little bit differently. And by embracing that kind of philosophy that Dr. Evans started as he was looking to ascend to the heavens and move from ground-based observations into the sky, that the existing technology was never that end goal. So it's that jumping off point. But you know, we do need to have that plan so that as we move forward with our missions, that we're preserving the best to continue that legacy. So with that, I encourage you all to think about how can we as preservationists aid future generations in their access to this history? How can we be adaptable and use pragmatism to help us preserve the space race legacy? And if I piqued your interest, Sunspot, the QR code will take you to the consortium's website where you can find out about tours and information going on. And there's also a link there that you can snap a photo of that you can provide donations directly to New Mexico State University Astronomy Department. Note that it's for Sunspot and the funds will get there. As you can imagine, the future of Sunspot still remains a question mark. It still remains largely vacant with just the one telescope in operation. A large nearly 140-acre campus remains largely dormant. So its future still remains in question. So by building support, continuing to share its story, I hope that we can move the story into the next century. And I'll leave you with this cartoon that I found from a 1953 newspaper. And the gentleman's asking the lady, you know, he's really crazy about astronomy and if they could go gaze at the stars. And she basically tells him, I'm a solar astronomer, I'm studying sunspots, and you're not welcome at my observatory. But hopefully our scientists and preservationists are a little more welcoming today. If you have any questions, you can reach out to me at my email or anytime throughout the rest of the week. Thank you.